I would like to welcome Dr. Al-Jaroodi and everyone attend today. Thank you so much, Dr. Al-Jaroodi, for giving us this kind of knowledge. We would really appreciate your help. And thank you to Reem, who communicated with Dr. Al-Jaroodi. You can start, Dr. Al-Jaroodi.
Okay. Hello, everyone. I started by the main screen that I had prepared so that you kind of get a feel of where we're going. So the Saudi Club and the RMU ACM chapter work together to make this happen. And I'm glad to talk to everyone here. I'll be talking about what cloud is and some of the general concepts of cloud computing that are picking up pace and affecting the technologies all around us. So if anybody has a question, please raise your hand or type it in the chat. I'll try my best to keep up. But if I miss any questions, I'll try at the end to come back to them and answer them. So please interject if you have anything. So the presentation is generally about cloud computing concepts. And I want to take you back in time about 70 years when computers just started. And on the screen, you see in the very beginning, it was standalone computing. That means one computer, one program at a time, nothing else can be done. And if you look at the picture on the top, it shows you a picture of ENIAC, one of the earliest computers built. Now, if you see this whole room now fits in the cheapest smartphone you can find. Over time, computers started to get a little better, the technology is better, but they were still too expensive for people to buy them. So they were more about businesses and organizations and governments who buy the large computers. And then what happens is, within that large computer, all you have is a connection to a terminal and a keyboard. And these are what we call the dumb terminals. So they cannot process anything. They only send your input to the computer. And then when the output is ready, it comes back and you see it on your screen. And that's what we call the time sharing. So several people can use the computer, but effectively they are ordered and executed one at a time. Moving on, computing became cheaper. Computers became a lot smaller. Now people can buy computers and they're able to do quite a few things on their own. However, the computers, they were still not strong enough and not powerful enough to do a lot of things. And upgrading and changing was very expensive. So time sharing came back. And now in a much better form by allowing the use of mainframe computers and supercomputers. So users now can actually get processing time on those machines based on some kind of an agreement or paying for it. So it kind of looks a lot like the earlier version, but now you have actual computers who talk to the supercomputer and they can actually work together to get work done. And later on, networking became more common. We have local area networks within buildings, and then it started to become bigger across buildings and then across cities. And eventually we got to the internet. So another concept was created where we have distributed computing. That means you have one central point, but it's not the one that does all the work. All the computers connected to it will be participating in that work. Several models came up. Lots of people tried to use it. I don't think any of you were aware when we came to a point when the move was, if we need a supercomputer, what we'll do is distribute the work on people's computers, and they can volunteer their processing time so that with that work, you can get thousands to work on the same problem and solve it faster. But a lot of logistics did not make it work. So that too started to fade. But now we are at an era where technologies are really, really, really advanced. You have huge different types of communication models, Wi-Fi, Bluetooth, 5G now, and of course the wired and cable, fiber optic communications. Computing resources are considered very, very, very cheap. My first computer cost about $4,000. Now I can buy a computer that is about 100 times as powerful for under $1,000. So you can see that difference that has happened. Software also has emerged in so many different ways. It's not contained now to just business applications or file processing or things like these. It became part of our lives in practically everything we do. So now we need more and better computing services. Standalone computing with our own computers, we can do as much, but there are points where we cannot do anymore. We need help from outside. Access to powerful machines started to become more common, and that's when cloud computing came into the picture. So cloud computing is, in a way, going back to the time-sharing model, but in a very new format. So now you share the model, the infrastructure, but the infrastructure itself is already distributed and huge. So you have many layers of components you have to deal with. So cloud computing, in short, is online, on-demand computing. And if you just try to analyze these two words, you should be able to get a good feel of what really is happening. It's basically a model to enable ubiquitous, convenient, on-demand. That's the on-demand word, basically. Network access to shared and configurable resources. That means you can have access to different types of computers and infrastructures, and you can actually configure them to do the work you want them to do. So that allows you that flexibility to actually be able to run things remotely without having to change what you programmed. Rather, you set up the infrastructure to what you need. So basically, this model now has evolved heavily. Well, some of the earliest uses of cloud computing model, before they even called it cloud computing, are things like email services. When we have the Yahoo emails and Gmail and Hotmail and all of these, more or less these are cloud services. The email server itself is sitting somewhere where the company that provides the email runs. And every one of us who has an account can remotely log in, check their emails, delete emails, send emails. And basically, it's not your computer that's doing the work. Most of it is being done at the server side. So that was the early vision or start of cloud computing, and that led us to what we have right now. So basically, there are 6 characteristics defining cloud computing. We said first it's an on-demand, and here you see it adds also what you call a self-service. And basically that means you do your own work, we'll give you the resources you need to make them work. Broad network access, it won't work unless you have really good networking, connecting all the components. Resource pooling. So now instead of having access to one computer or maybe 2 computers, the cloud providers can give you access to any and everything they can have control on. And now you can actually access anything, anywhere, without having any issues. So if you drop a document on Google Docs, you can access it from your computer. If you're visiting someone and you need to do something quickly, you can use their computer and log into your account and do something. You travel, you can use other places to do that, and it doesn't really matter. You see what you have and you can do with it whatever you like, even though it might be sitting like thousands of miles away. Rapid elasticity. This is something that is distinctively new with the cloud models. You've seen rubber bands, and if you pull them, they expand, and if you let them go, they go back to their normal form. And that's what we call elasticity. And when we're talking about computing, elasticity means being able to change how you do the work depending on what you need. And a lot of cloud providers now are using this to promote a lot of the services they have. That they're saying, for example, you can maybe get one single virtual machine for your web server and run it. And if you get more demand and more, it becomes popular and more people start to go into that, and your machine is not capable of keeping up, you can very quickly upgrade to a larger one or add another one to help with the work. That's elasticity, growing when the demand increases. And it can do also the other way around. You add a few machines, and then after a few months, you lose the popularity. Not many people are coming in anymore. Why pay for all of those? You can drop them down to one or two that are enough to do the work at the time. Now, to make all of this happen, the cloud services have to be measured, because as you've seen in the model, it's more about paying for what you use. If you buy a computer and take it home and install software and use it, it doesn't matter whether you use it 5 minutes a day or use it 10 hours a day. It's yours, you're using it, it doesn't really matter how much work you're putting on it. When you're talking about the cloud, it's like renting something, and renting it based on how much you're gonna use it or how long you're gonna use it. And that means that has to be measured. So the provider can see how long you've been using, how many resources you have used, and based on that, send you the bill and say, you owe us this much because you use this, this, and that. And that's basically what measured service is. And that created the business model. So companies now can actually offer cloud services in a commercial way. So another thing that comes up, and I've seen people ask about, why did they call it cloud? And basically, the name cloud came from an earlier depiction of the internet. Early on in the days when internet started to come up, the designers and developers didn't really have something to represent it when they put connection diagrams or something like that. And they didn't know what to put about it. They had routers and switches and a few other networking components, but none of them does everything that the internet can do. So they said, okay, let's just put a cloud in there and we can fill it up later. And it just stayed. And it became the symbol for the internet. Now the internet has become part of our lives. We don't even need a symbol for it. So cloud computing picked up that same symbol and used the name for it. And that's where cloud computing came. So if you have cloud computing available, you can do a lot of things that you can never do on your own computers, or even sometimes within a whole company's set of computers that are available, because you need a lot more and better organized resources. So you have, for example, massive scale computing. And that means if you need to do calculations that take long time. A lot of work to be done, millions and millions and millions of instructions that have to be executed over and over again. And regular computers may not be able to do that. So if you think about the problem that if you solve it on a desktop or a laptop will take a week to complete, you can drop it on the cloud and ask for a really powerful computer that can finish it for you in a few minutes. Homogeneity, basically that's because now the cloud services come in ways that shows you or presented to you in a very similar way across the board. So knowing how to deal with it becomes a little easier. You have different services, but you have also well-defined ways of how do I use these services. It allows you to do a lot of virtualization. When you go to a cloud provider and say, I want a virtual machine, and you rent that, when you start working on that virtual machine, it will feel as if it is your own computer sitting right in front of you. So it's not your computer, you're not using your own processor or memory, you're using the cloud component resources, but as you use them, the way they kind of provide you that image of the hardware, it feels like you're actually using the real hardware, even though your jobs or your applications may be jumping around on different types of hardwares from time to time, but you never even feel that because you don't really need to care what computers they're using. Offering resilient computing, that means you can do your computing requirements even if the environment or the operation conditions are not really very good. For example, you're here, you're on campus, and you have to do some assignments, and power goes out. If you have your laptop, you may be able to do some work. But if you are already working on something on one of the lab machines and you don't have access to it anywhere else, that's it, you cannot do anything. And in the cloud, they don't allow anything like this to happen. Everything you use on the cloud will be duplicated, because they know that things can go wrong. And basically, if some servers fail, they can actually get your job to work, even if it's a little slower, but they still keep it running and capable of doing the job it needs. And that's what resiliency is. And of course, it helps lower the cost of a lot of software. Because the service providers have made those services and they practically offer them for thousands of or millions of clients, they can afford to drop their prices because they develop it once, but they sell it thousands and thousands and thousands of times, and that lowers the cost. And sharing those software components becomes more effective as more clients come in and start using them. So this is something we call the economy of scale. That means if you are bigger, you can survive on smaller profit margins. So you can make your products cheaper. Geographic distributions, of course, for you as a user, you will, or actually for the provider, they will be able to place their computers and data centers and all those resources anywhere in the world. And their client doesn't even need to know what happened. They can move systems from one area to another, create a new data center in another city and move some of the work on it. All of this happens behind the scenes. Users don't really care what's going on and they don't see it. So that's basically what it does offer as a set of services. Now, when you look at it as a client, as someone who wants to use the cloud, you also get a lot of benefits. You have a lower cost of ownership because now even if you need very, very powerful computers, you don't have to buy them. These are very expensive. And especially if you're not going to need them like on a continuous basis, but let's say half of the time, why pay for those machines if you're not going to use them all the time? So that way you can actually go to the cloud providers and say, I need this kind of processing power, and then you can rent that from them. You get highly reliable and available services. Again, the cloud providers are responsible for keeping their infrastructure up and running at any point of time in any condition. And if that stays correct, or continues, your applications on top, unless your own application fails, will not have any issues. Users can also get the application programming interfaces, APIs, that allows them to actually incorporate using the cloud with their actual programming. Well-tested security features. And this is a point of argument, and I think some of you probably have that question as well. How secure is the cloud? Now, if you think about it externally, thinking that, okay, I have some of my stuff on my local computers and I have some of them on the cloud, and I have to need to change or move things around back and forth, and that will expose them to a lot of security problems through the internet. So that's one argument. Thing is, if you look at it from the technical point of view, how do you protect your data and your computing facilities? You have to implement several things that will help you do that. Adding antivirus software, incorporating algorithms and programs that can detect attacks, including software that can help you manage issues if they happen, software to encrypt your data, software to secure your data when it's traveling over to other places. You have to do all of this even if you're using your own machine, and no matter how much effort you put in it, you can't block all the holes. You solve a problem, another one comes up. And if you just keep running behind those problems, trying to solve one after the other, you lose a lot of time, a lot of cost, and a lot of resources. On the cloud, because they're huge, and because they have a lot of stake and risk in terms of security, they can afford to investigate and create solutions to every and any possible security problem that may come up. You see the difference? And now, basically, when you subscribe as a cloud client, you can make use of those security features to protect your own applications as part of the system. Again, as a user as well, you have global access to all resources. And if you use cloud machines, that means you don't need to buy a lot of computers in-house within your business or organization. You don't have a lot of computers in-house, that means you don't need people to take care of them. And that reduces your operational cost over time. And of course, you get that flexibility because cloud providers can offer you this elastic growth component. You can start at any size for your applications without having to worry what will happen a year from now. So if you're buying the hardware, usually businesses will have to kind of have an estimate of how the demand will be on the applications that they have over, let's say, 2 or 3 years. And then they will buy these resources, the computers, based on the highest number they get to. But they might never get to that until like 2 years in. On the cloud, you don't have to think about that. All you have to do is, what do I need right now? And you provision that, you get that. If your needs increase, you can easily go in and add more resources. Your need decreases, you can go in and remove some resources so you don't pay for them. So this is the major set of advantages for anyone trying to get into cloud computing. This graph shows you a little bit about how cloud computing has grown over time. Generally, the concept started around 2010, give or take a couple years, but this measurement was done since 2011. And if you see the top blue line is the percentage of IT and CTO managers have at least, say that they have at least one application or part of their computing infrastructure on the cloud. And if you look at the number, it has jumped from 51% all the way to 73%. If you look at the bottom line, it says companies or managers who plan to use the cloud within the next 1 to 3 years. So at the time they asked them, they said, okay, yeah, I think it's good, but I will do that later on in a year or 2 or 3. At the very beginning, 2011, there were 21% of those. Now you only see in 2018, only 10%. That means there is that difference between the two. The 11% are people who probably moved from that line to the blue line because they actually adopted some cloud solutions. And here are some numbers. These are not accurate. They're just estimates that were done by a surveying company that shows you how much revenue you can make or the cloud service brings into the cloud providers. So just to look at one example, cloud application services, SaaS, somewhere it's just in the middle. In 2019, the return was 102,000 millions of dollars. If you look at 2022, it's estimated to go to 140,000 million. That's a 40% growth, give or take. So it's one of the areas that you see things are growing significantly fast, basically because more and more people starting to use more cloud services. Deployment is just how do you use the cloud in terms of ownership. And when we use something like Google Docs and Gmail, we are actually using what is known as a public cloud. That means it is open. Anyone, anywhere in the public can subscribe and use the services that are available there. On the other end, you have the private clouds. And this is a model that now a lot of the big organizations are adopting because what they're doing is they reconfigure the computers and the software that they have in-house to act like the cloud. So it becomes their own private cloud that they own, they control, they can do anything they want, but no one else can have access to it. And because of that, we were able to go to things like community cloud, where some organizations, some companies get together and say, okay, we have resources here and here and here, but why don't we put them together so that everybody have access to those? And in that format, they create what we call the community cloud. And the hybrid cloud is basically using a mix of private, public, or community deployment in your applications. Do you have any thoughts or questions? Let's see. Oh, I don't see anything on the chat. Okay. My rule is I wait 5 seconds. If I don't hear anything, I move on. So that means let's go on, and now we'll talk about the second part, which is the service models. And this is the most crucial part for anyone to really get a good grasp of whether they are looking into becoming cloud service providers or cloud users or cloud designers and consultants. At any level, you need to be fully aware of what's going on in these different levels. The earlier use of the cloud was more like using virtual machines. So if you use VMware, it's kind of similar. It's like you're using a virtual image of a lab computer on your own browser. So IaaS is infrastructure as a service. And that means if you use that, you're barely getting, or you're getting the bare metal. That means just the computer and the operating system on top of it. Nothing else is on it. So kind of like buying a new computer with only Windows on it or Mac OS, no applications and nothing else is happening on there. And then as a client, it becomes your virtual machine and you can do whatever you want to do with it. It's a computer at the end. And you can do all of this on your own. You can also provision something like just remote storage. So you can store backups for some of your data. And in this case, you don't really need any software. All you need is a storage device. And they can virtualize that for you and you put the data on. So infrastructure is mainly about the bare metal. And if you move to PaaS, and that is called platform as a service. Now, a lot of people confuse infrastructure and platform, but there is subtle differences between the two. As I said, infrastructure is bare metal. That means the machine, operating system, stop, nothing else. Platform as a service is a virtual machine, just like you get the infrastructure, but you get on top of it some common services. Like if you need to use a database, you can actually reserve a database engine where you just put your data on it and you can use it. If you need a special type of storage, you can provision that special type of storage as a platform, and it becomes your basis for working on other parts of your system. So it gives you the runtime environment, the platform, and allows you to choose the resources you need on top of that. The highest level is software as a service. And this is basically general types of applications that are available, and you can actually just subscribe and use them. And in this case, you don't even have to care about how they were implemented, what hardware they're using, how they're set up. It doesn't really matter. RMU now uses Gmail for their email services, and that's the software as a service. So what happens now is IT have no responsibilities for the email system whatsoever, because the service itself is just provisioned as is from Google. So the only thing that the IT is responsible for is making sure that they create the accounts correctly, remove older accounts, add new accounts, and so on. But the server itself, how much storage is taking, what's happening inside it, they don't care. It just happens. So you get complete solutions for different types of services that you need. So it kind of looks something like this. If you provision only the IaaS, the infrastructure, you're getting only the bare metal. The platform as a service gives you some additional basics for actually building and deploying applications like database engines, storage devices, and file system management, for example. And then if you go on top, which is the more common area where you see more tangible uses of the cloud, is where you have the actual applications happening in there. So that's where you go with these different ones. So I already explained these in detail, so I'll just skip through them. Recently, in the past few years, more service models came into the picture. If anybody heard of DaaS, BaaS, MBaaS, IoTaaS, NaaS, all of these are new names that are coming up for specific types of things that you can do on the cloud. So DaaS is called Data as a Service, and basically it provides you with services that can do something with data, like high volume processing, like analyzing the data, like screening data for specific values. All of this is considered services related to data. BaaS is more about the back-end development. It allows you to have services like web server, the database engine operations, all of these that happen behind the scenes so the users can interact with them through the web. Possibly many of you have heard of IoT, Internet of Things. And this concept is growing pretty fast as a way to create better connections and controls over different types of systems using sensors. So IoT is basically any device and any sensor that has network capability. So a smartwatch is an IoT. A thermostat that can be controlled from the phone is considered a thing on this Internet of Things. And now cloud providers are looking into offering services that are specifically designed to use these in easier and better ways. And there are quite a lot more. If you look them up, you'll find a lot more than I have listed here, but it's just growing. Cloud market growth, just to give you a quick example. In the infrastructure as a service, the top providers are Amazon, Microsoft, and Google. IBM trails behind them. If you look at software as a service, it's more Microsoft, Salesforce, and Adobe, because they offer a lot of software-based solutions rather than the hardware that you need. Public versus hybrid, you see they have grown as well. And cloud data centers have also grown very fast. And now is a little bit of the general things. I think some of you, if you attended the earlier sessions with Dr. Brummel about AWS on the cloud, you've seen a lot of examples of Amazon Web Services and how they offer these services. Now, each and every cloud service provider has a similar type and set of services. The naming may be different, but the functionality is always the same. So if you say EC2 and AWS, that's Elastic Compute Cloud, that's basically provisioning a virtual machine. In IBM Cloud, they're called virtual machines. And in Google, what do they call them? Compute nodes or something like that. So they still do the same thing, but they're just called different names. Now, the leaders now in the general market of cloud service providers are IBM, Amazon Web Services, Microsoft Azure, Oracle, and Google Cloud. There are many, many, many others that are also available, and some of them are picking up pace and starting to grow very big. So here's an example comparing AWS, Azure, and Google Cloud. AWS is the earliest, the very first one to actually commercialize cloud services. They spread their data centers across 25 regions around the world. Microsoft has 54 and Google has 21. Key offerings. So AWS offers compute resources, and if you look at the other two, they all have it. Storage, everybody has it. Database, it says data management here, which is the same, and databases here, that's also the same. Networking across the board. AI, also across the board. So as you see, a lot of the things you see in any one of these, they have a lot of similar services. These are the common names for them, but within each provider, they kind of give you a different view of and naming procedures. And if you look down there, it's the annual revenue for each company. That was, I think, 2019, give or take. So AWS was made 33 billion. Azor made 35 billion, surprisingly higher than AWS, even though their infrastructure is slightly less, a little bit smaller. Google Cloud is the lowest of them, and so far it's not picking pace in terms of popularity. Now, the difference in revenue between, for example, Amazon and Azure is basically because Amazon has dominated mainly the infrastructure as a service, and that is the cheapest type of cloud computing services that you can get. And it's building up towards platform as a service and software as a service. Azure focused mostly on software as a service. And these are the expensive part, because now you are actually renting full-fledged software. So if you think about it, it's like if you rent a bare apartment that has nothing except the walls and ceiling and floor, how much you'll pay for that, versus you rent a luxury, fully furnished apartment. Same size, same location, but you still pay different amount of money because the other one is furnished. And that's basically the difference. When you go to the software as a service, it's more like getting something that is completely done, ready to use, drop and use. That's it. And that's why there is a difference in the revenue value. So this is an example for the software as a service. It shows Microsoft as the leader, Salesforce, behind it, Adobe, SAP, Oracle, and there are several others that are less than that number. And in the infrastructure as a service, you see Amazon leading heavily in front of all the other providers, Azure, Google Cloud, Alibaba, IBM Cloud, etc. What I'd like to do is take a few minutes and kind of give you a quick tour of some of these providers. By the way, all four of these providers provide free trial accounts. So anyone can go in, create an account, and use a subset of the resources they have on the cloud to experiment, try it out. I had several students in the past few years. For example, they are building an application, a mobile app that requires a back-end server. Instead of having to provision their own and keep their computer running 24/7, we worked together and set up an AWS account, which they can get for free for a whole year. And they provisioned a virtual machine and they installed everything they need up there. And they have full-fledged running server for a whole year that they can play with and experiment with. IBM, Azure, and Google Cloud also offer very similar type of accounts. They differ in what type of services are allowed, how big or small the environments you can use, but they all give you some of these things. So let me just pull out of here. I'll show you something. This is something I was looking at. I actually have accounts on AWS, IBM, and very recently I wanted to set up the one on Azor, but I don't know what happened. I didn't get a chance to do it. But this is how the AWS Management Console looks. And what I'm interested in showing you is just some examples of the services they offer. So this is a big list of different services that they have. EC2 is the most common. That's an infrastructure as a service. And basically that's, if you provision or rent one of these, it's basically like having a virtual machine for yourself. The following parts are also relevant to compute requirements. They go into a little more advanced services. They also have storage services that you can provision. S3 is very basic. It's huge and it's pretty cheap. You can drop thousands and thousands of gigabytes on it and it doesn't really cost you that much. If you go to something like BFS and FSX, they're in different architectures, but they are usually more expensive. Another important set is the databases. Now, this is most of these are platform as a service. So you can actually get relational database like MySQL. They already support that, so you don't have to install MySQL to run queries. All you have to do is put your data there. They have other databases that they offer like DynamoDB and several others. Another thing that is interesting, and I possibly would recommend you, if you're interested in cloud computing, is looking at the cost management. There is the first service here is called AWS Cost Explorer. And what it does, it actually gives you an estimate of how much it will cost you if you set up a certain set of resources for yourself. So you don't have to actually have those provisioned. It just gives you estimates if you want to use them. So it gives you a really good way of looking at the different configurations and allows you to put together, for example, if I take 4 EC2 instances, this much storage on S3, this database, that kind of network, and you can just put them in and it will actually calculate and show you how much it's gonna cost. So let me see. That's probably not the one. Let me see. Should be the one. It might have logged me out because I'm not being able to connect to anything. This is another area where you actually can see if you have an account, how much, what did you use and how much it costs. My account is brand new. I just set it up yesterday. So I'm on the free tier, but I haven't used anything in either set. So it says 0 here. You can actually set it up to send you messages if your spending reaches a certain amount or if you have certain levels of usage for some resources. So you can actually go back and see how things are happening. Now, this is, IBM Cloud main page. And again, you see, these are generic, most popular things people want to do, so they put them right on top. But then you can go in to the menus and you can see what you have. Of course, I haven't really started anything on there. It was a new account, so I want to pull out some information. And this is what they call the cloud architecture. And here it shows you the different things you can do. For example, you can provision a virtual server. That's very similar to the EC2 you've seen in AWS. And this one is particularly for virtual private cloud. So you can protect your applications. Power systems, these are high performance computing that you can have virtual images of. Hyper protect virtual servers. And this is basically heavily secured type of servers that you can put together. It even allows you to provision bare metal. That means it doesn't even have an operating system. You just get the computing hardware and you have to deal with installing your own operating system and doing more work with that. There are lots of software services that you can put together. Virtual private clouds, Apache backend servers, you can use those. ASP.NET engines. So you don't even have to have those installed anywhere, but you can just use them from there with your own programming and models. So you see a huge set of different services that they can offer you. And if you go to this page, this is the Google Cloud. Let me see if I have a good review of the different services. Well, this page basically shows you what you get when you get the free account. What they do is they give you a 90-day trial period. That's 3 months with some actually monetary credit that you can use. And if you don't renew that, you can just fall back to what is called the free tier, which allows you for a limited number of services, but you can access them practically anytime, all the time. And finally, this is Azor. And again, they also have free tiers. It shows, for example, what you can get: Linux virtual machines, managed storage, file storage, SQL databases, archiving storage. So you see there are quite a few different services. But I hope you did notice that among all four, 1, 2, 3, and 4, what is the third one? 3 and 4, although the wording sometimes is different, more or less you can get very similar services across all of them. So I think we're almost running out of time, so let me just jump in and give you just a couple more things. This is just an example that I pulled for cloud service costs, and that's where you can use them to estimate. IBM also offers you something very similar. So you go in and say, I want this machine, this database, and so on, and it will actually give you how much it's going to cost. Here's an example of operational costs, starting with in-house system, that's the dark blue lines. And from there, with the decision made to move on to the cloud until they actually are on the cloud. So they started the first year with only preliminary studies of what they want to do and if they want to go for the cloud, testing a few little things here and there. So their original operational cost is exactly the same. It doesn't change over about 3 quarters. But you see the gray line starts growing. And this is basically the cost of migrating what you have on your local machines to the cloud, along with the cost of using the cloud, which is the light blue. And for a couple of quarters, which is generally the time it takes to transition from in-house to fully on cloud, you have high costs for that transition. Cloud costs start to grow bigger, but your in-house cost starts to drop, because during this 1 year in the middle, although you moved everything to the cloud, there are lots of services that cannot just move like that. So it takes time to gradually move them up. And this is the last time where the local infrastructure was in use. At this point, you have everything already ready and running on the cloud. So you switch off the local machines and you end up now with only the costs for the cloud. Again, if you look at the cost for the cloud, we're still using the exact same applications across the board, but the cost over time starts to go lower, basically because most cloud providers will give you tools to monitor and optimize resources that you use so that you lower the cost until you get to a fixed cost level. So this is your measuring line. These are the extra transition costs, but as soon as you hit the level here, now from there on, your cost to operate the exact same set of applications and resources you had in-house, instead of $400,000 a year, you go to under $200,000, half the cost. So in a way, in a few years, you pay back this transition cost, and then it becomes revenue all across the board. So one last slide, I won't go through the rest. It's just kind of looking at it, whether or not we should or we should not use the cloud. And the debate is still going. There are three aspects. There's the social issues, people who still do not want to go to the cloud, people who are already used to certain things and how they do them. And basically the main question is, should we go to the cloud or not? The next question is the technical issues. How do I do this? If I decide that I want to go to the cloud, you come to the next question. How do I do this? And if you figure out a little bit about that, you have also the labor issues. Who can do this? And that last point is the major bottleneck right now. I've seen a lot of cloud consultancy companies saying that they have to turn down more than half of the requests for consultations to go on the cloud, basically because they don't have the manpower. There aren't enough who can do this. So you can imagine how that would look like over time. So I'll stop here. I'm not going to take more than a full hour. If there are a couple questions, we have a few minutes, I can answer them.
I didn't have any questions, but I just wanted to say this was definitely a successful event.
Thank you, Riley. Appreciate that. I really hope you came out with something out of this, if not everything.
Thank you, Professor Jameela, for sharing this great knowledge with us. I hope you have a good time with the rest of your day. Thank you so much thank you so much for ACM Club who cooperated with our club to do this workshop.
Thank you so much. Appreciate that. And thank you for everyone who came and listened to me rattle on for a whole hour.
Happy to work with you guys.
Oh, thank you so much, Ayer.
Thank you. You all have a good day.
See you soon.
Thank you.
You too. Thank you.
Thank you so much.